Okay, this is Mr. Burgess. I'm excited about today's lesson. We're going to be talking about exponents, and we have prepared for you an Introduction to Exponents guided notes. Now, if you're watching this at home, those notes are available on the Today button link, and you can print those out and fill these out as you go. Now, as we go through these guided notes, they come in sections like Section 1 is a definition, Section 2 is some more example problems. But not everything that you see on this lesson will be going into the guide notes. So some of them are practice problems in between the concepts. So I'll try to point out where you're going to write stuff down and where you're just going to be focusing on watching and paying attention. Okay, so the next thing we want to talk about is what is an exponent? And if you're watching at home, you could watch this video by Mathematics Introduction to Exponents. It's an excellent video, and it will also help you with these guided notes. So, number one, exponents are just repeated multiplication. So here's some examples of repeated multiplication. So if you look, you've got three 2's together here. So if I wrote those as an exponent, it would look something like this. 2 to the third power. So kind of strange looking, but you've probably seen something like that. If the numbers have parentheses around them and you're writing it as an exponent, make sure you can include the parentheses. So -7, and I have two of those, so -7 to the second power. How about 2/3? You can do it as a fraction. 1, 2, 3, 4. We have 2/3 5 times. So 2/3. And sometimes I'll put a parenthesis around these because I want myself and everyone to know that I'm multiplying 2/3 by itself 5 times, not 2 by itself 5 times over 3, but the whole fraction. The next one, -1/6 in parentheses to the third power. And the last one, 11. How many times have we got 11 written down there? 1, 2, 3, 4, 5, 6, 7. So 11 to the 7th power. And that's all we mean by exponents are just repeated multiplication. So you can write these interchangeably. They both mean the same thing. All right, number 2, exponents have two numbers. So if you look at your guided notes, the base gets multiplied repeatedly, and the exponent tells how many copies of the base that you make. For example, 4 to the second power means that you have 2 copies of 4, so you'd have 4 times 4 because of that. All right, moving along. Number 3, to enter an exponent into a computer or scientific calculator, you use the caret symbol, which looks like this. Now, not all calculators require you to do that. Some actually have an exponent key that's easier to work with. But on most computer programs and on the calculators we use in our classroom, this is what you need to do. So if you wanted to find 2 to the 5th power, you would just type the number 2. Then you'd find the little caret key that looks something like this. And then you type the number 5. And that would be 2 to the 5th power on our calculator. All right. Now exponents, number 4, exponents do not have the commutative property. So what we want you to make sure that you don't make this mistake. If I have 2 to the 5th power, that means 2 times 2 times 2 times 2 times 2, 5 times. Well, I can't switch those numbers around and get the same result. 5 to the second is not the same thing. That would be 5 times 5, which is definitely not the same value as 2 times 2 times 2 times 2 times 2. So remember, you can't switch these numbers around. Number 5, exponents are repeated multiplication. So exponents are just repeated multiplication. So if you think about it, 3 to the second is just 3 times 3. 3 to the third is 3 times 3 times 3. And so on, with 4 3's and 5 3's that you can see there. So if you have your calculator handy, you can either do it either way. You can put 3 to the 5th power and then equals, or you can do 3 times 3 times 3 times 3, however many times it tells you to do it. But you're going to find out that exponents are a much quicker and faster way to do this, especially when you have a lot of numbers being multiplied. So let's practice a couple. So number 6, 6 to the 4th power. So we're going to use our calculator. Now I've grabbed a calculator that's very similar to the one that we have in the classroom, just a little bit different. So this is going to be 6. I hit that little caret key. And so this has got a little box that's flashing now. Yours may not show the caret key or this flashing box. Yours will actually may just show the little upper facing arrow. So now I'm going to type in the number 4. So 6 to the 4th power, and I'm going to hit enter. And so that would just be 1296. How about 7 to the 6th power? So I got to clear the one that I have here. So I'm going to do 7 to the 6th power. Oops, it didn't like that. 7 up there. Oh, let me make sure I got everything taken care of. The number 7 raised to the 6th power. Enter. Well, that's a big number. 1,17649. One thing I've noticed when I'm using one of these online calculators, it doesn't show both on this page. So I have to kind of go back and forth. So the next one, 5 to the 5th power. So let's clear our old result. Now 5, upper caret, 5 to the 5th power, enter. So that's 3125. So 3125. And then 2 to the 9th power. Let's do that one. So clear out our old result. Then 2 raised to the 9th power. And then hit enter on your calculator. So that was 512. So depending on what number you start with and how many times you multiply it together, you can end up with some pretty big numbers. And that's why we like to use exponents, because it's a way of writing a big number in a really concise way. Okay, so to evaluate an expression, this means to calculate its exponent. So here's 4 different problems. And you notice these are written a little differently, so I want you to notice that if a problem starts out with a set of parentheses on it, you want to keep them in there when you calculate or evaluate the answer. So let's go back to our calculator and hit clear. So in this case, we want to put some parentheses in there, and we have -2, and then I'm going to raise it to the 4th power, and then hit enter. And that ends up being, I don't think that's right. I got to go back and check that response because I think it's supposed to be positive. So let's make sure our parenthesis works. -2. Now if I hit up arrow, there we go, to the 4th power and hit enter, I get the number 16. So that's important to remember. If you have some parentheses in your original problem, make sure you put them in there when you evaluate it, because sometimes it makes a difference on whether or not you get a positive or negative number. Our next one is -3 to the 3rd. So parentheses, -3, and we're going to raise that to the 3rd power. And we hit enter, we get -27. Interesting, so this gives us -27. -2 to the 4th power without the parentheses. -2 raised to the 4th power is -16. That's a different result, right? You got a negative number there. That's kind of surprising result. How about negative 3 to the third? Well, it turns out that it is also negative 27. So some interesting results. So when you're going to evaluate these, make sure you use the parentheses if they're in there, or if they're not, enter them on your calculator correctly so that you can get the accurate and correct results. Okay, so here's a few more that you can do if you'd like. We don't need to do all of them, but we can do a few if you'd like. Now let's check out this fraction though. If you put in 1/4 to the third power, you end up with 1 times 1 times 1 on top and 4 times 4 times 4 on the bottom. And 1 times 1 times 1 is this 1 on the top. And what's 4 times 4? Well, that's 16, and then 4 times 16 would be 64. So you can actually put these on your calculator in fraction form with an exponent, and it'll give you the new fraction, which is pretty nifty. Okay, number 7. Some of the most common exponents that we see is the numbers 2 and 3, and we want to make a couple of comments. Whenever you see a number squared or x squared, that means that number, or 2 means squared, another name for it. So whenever someone says x squared or 3 squared, that just means take that number to the second power. And the reason that we like to use the terminology square and 2, because when we talk about the area of something, like the area of your front yard or the area of your living room for a new carpet, we talk about area in square units, like square feet or square miles, or whatever the case may be. Now, if you see the word cubed, that usually means an exponent of 3. So like 4 cubed would be 4 to the third power. 5 cubed would be 5 to the third power. And cubic units are used to describe or to find the volume of something. And whenever you find the volume of like a rectangular prism or a cylinder or a cone, the units are expressed in cubed units. And we'll do a unit where we actually find volume doing that kind of thing. Okay, exponents is a power of 10. This is number 8 on our guided notes. So we're moving along. We only got a couple more sections here. So if you notice, the exponent gives the number of zeros, and if you have the power of 10 results in a 1 followed by this number of zeros. So if I have 10 to the third power, that means 1 followed by 3 zeros. If I have 10 to the fourth power, that means 1 followed by 4 zeros, and so on. 1 followed by 5 zeros, 1 followed by 6 zeros. Okay, so let's evaluate this one. So this would be 1 followed by 5 zeros. And usually you'd have a comma right there, so that would be 100,000. What about 10 to the fourth? That would be 1 followed by 4 zeros. Okay, so 1 followed by 4 zeros, which is 10,000. How about 10 to the third power would be 1 followed by 3 zeros. 10 to the second power, 1 followed by 2 zeros. 10 to the first power would be 1 followed by 1 zero. Interesting. Well, what would 10 to the 0 power be if we followed the same pattern? If we drop a 0 every time, 10 to the 0 power would be 1. Because we just dropped the 0 off of this one, and that would give us the new number. Which is a way of showing and demonstrating that anything to the 0 power equals 1. So anything with the power of 0 is just equal to 1. And it doesn't matter, and this is number 9 on our notes, it doesn't matter what number it is. For example, 3 to the 0 power is 1. 7 to the 0 power equals 1. 109 to the 0 power equals 1. So it doesn't have to be a power of 10 for this to work. And so whenever you have an expression where you have something to the 0 power, you can immediately replace that part of the expression with the number 1 to help simplify it. Okay, so today our assignment is number 54, Introduction to Exponents. It's on Alex. You do not have to show your work. You just have to submit a screenshot of your score, but you may want to use a marker and a tissue or something so that you can keep track of things on your desk while you're working them out, or you could put it in your notebook so it's something you can remember. So thank you for watching this lesson, and good luck.